Howdy! The point of this video is to talk about geometrical isomers. Now, there are different ways that we can arrange repeat units to make a large polymer molecule. However, there are also different ways that the repeat units themselves can be structured. And these differences have important effects on the properties of those polymer chains. So, geometric isomers are referring to different unique arrangements of side groups within an individual repeat unit. So let's look at an example of some of these. In this case, we have two different kinds of side groups. We have propyl groups, which are composed of a carbon with 3 hydrogens coming off it, and we have a single hydrogen atom as a side group. Now you'll note that there is a double bond between those two carbons, and that's really important. It's going to become clear why momentarily. So we can have two different kinds of arrangements of these side groups. We could have what's called the cis arrangement, whereby the propyl group is next to the hydrogen group, or we could have the trans arrangement, whereby the propyl group is diagonally across that, that repeat unit from the hydrogen group. Now, it's important that you have a double bond, because that is what creates a stiff backbone and stops that backbone from rotating. And you need that stiff backbone because if you rotate, then you can go back and forth between that cis and trans configuration. So let's look at a couple examples on a 3D model. These are two different repeat units. In one case, I have the trans configuration. So this side group is diagonally across the repeat unit from this side group. In the other case, I have a cis configuration. So these two side groups are next to each other. Now there's no way to rotate this to go from one case to the other because that's a double bond. And remember, double bonds don't allow for free rotation along those axes. So I could form a polymer chain by combining a bunch of different ones. And typically, during the synthesis process, we're either using cis or trans configuration type repeat units. So this is a polymer molecule that's composed of repeat units in the trans configuration. So just as a comparison, we could look at things that have a single bond. And you could say, okay, well, here those unique side groups are next to each other. Here they're diagonally across. But remember, single bonds are free to rotate. And so you can get configurations whereby we're going back and forth between that cis and trans. And cis and trans really has no more meaning. So you can't have geometrical isomers when you have that single bond. Okay, so just really quickly in review, geometric isomers, it's talking about the structure within a repeat unit. It requires a double bond. And the two terms to remember are cis and trans. That refers to next to and across.